my today's session on electromagnetic field, and that is electromagnetic wave propagation. Myself, Dr. Sayanti Chatterjee, Associate Professor of EEE Department, Institute of Aeronautical Engineering, Hyderabad. So, electromagnetic wave equation is nothing but the application of the electromagnetic field. Light wave, sound wave, or magnetic wave, all the waves can be treated as the electromagnetic wave propagation. So today we will discuss about the electromagnetic waves. What is electromagnetic waves? Electromagnetic wave, also called as the electromagnetic wave radiation. Electromagnetic waves is known as the electromagnetic wave radiations, are basically defined as superimposed oscillations of an electrostatic wave of a magnetic field. So what is this? You can see this figure. First of all, we have one electrostatic. This is the electromagnetic wave is the transverse in nature. It will not go parallelly to the ground or perpendicular to the ground. It is some transverse in nature. Electromagnetic wave is the superimposed oscillations. It is oscillatory. So first point we will get here, it is oscillatory, means this is a time varying wave. It is the superimposed of the electric field and the magnetic field. It is the superimposed on electric field and magnetic field. What does it mean? You can see from this diagram, the blue one is the electric field, which is the AC in nature, and the red one is the magnetic field. The magnetic field, red one, is the field density is beta, and electric field intensity is E. The wavelength of the both we have taken as the lambda. So, if this is the case, then they will superimpose on each and other, and they will get a new wave, and this wave is known as the electromagnetic wave. Electromagnetic wave propagation is in the space of the direction of propagation perpendicular to both of them. We know from the Ponting theorem, P is equal to E cross H. What is E? E is nothing but the electromagnetic wave. What is H? H is nothing but the magnetomotive force. So E cross H means both the P direction should be EH sin theta, and the direction should be in the perpendicular from the EH plane. If E and H create this plane, it will be perpendicular. It will go from E to H, and from the right hand screw rule, we will get the direction of the electromagnetic wave propagation. So, electromagnetic wave, the main example of the electromagnetic wave is the light wave. So, next we will discuss about the properties of the electromagnetic wave propagation. What are the main properties? Number one, this wave travels at a speed of light. How we can get? We know that the speed of light we will get from the speed of light is equal to root. First we will calculate, it is an electromagnetic wave, means it will go through the dielectric medium as well as it will in the magnetic medium or ferromagnetic. So if we calculate the 1 by mu naught epsilon naught, we will get 3 into 10 to the power 8 meter per second, and it is the speed of light. So the waves of if the waves travel at the speed of light, and when there is a speed of light, we know m from the Einstein's law, E is equal to mc square. So if any particle goes in the speed of light, there is a huge energy. So that there is some energy in the electromagnetic wave. These waves do not require any medium for propagation. So whenever these waves are moving, these waves do not require any medium for propagation. No medium is needed. It can go in the air. So these waves do not require any medium for propagation. It can go from one place to another place without any conductor. Now we are using the mobiles. The mobile wave is an electromagnetic wave. So when we are talking in a mobile, it will starting from the sending end and the antenna, and receiver end is getting the data. There is no conductor in between this. But in the old time, when we are using the landline telephone, there is the telephone conductor. So electromagnetic, or we can take the example of lights. The light waves don't need any wave or any light. So electromagnetic waves do not require any medium for propagation. As I told earlier, electromagnetic waves travel in a transverse form. As we know, P is equal to E cross H, or EH sin theta. It will go in a certain angle, and this is the transverse form. Electromagnetic waves are not deflected by electric or magnetic field. If we give any electric field or magnetic field nearby, it will not deflected by any electric field or magnetic field. These waves can be polarized. We can polarize in if we send the waves in a potential field, it can be polarized. And if the wavelength is sigma, frequency is nu, then the EM waves can be related with C is equal to V nu, where C is the velocity of the wave, which is equals to the speed of the light, and V is the frequency. Actually, it is nu is the frequency, and lambda is the wavelength. So these are the main properties of the electromagnetic wave propagation. This wave travels at the speed of light. These waves do not require any medium for propagation. Electromagnetic waves travel in a transverse form. Electromagnetic waves are not deflected by the electric and magnetic field. The waves can be polarized. The electromagnetic waves undergo interference and diffraction, and C is equal to V nu. So these are the properties of the electromagnetic wave propagation. Next, we will discuss about the modes of propagation of the electromagnetic waves. As I told earlier, given the examples of the mobile phone, or you can take the example of the satellite in our TV pictures or anything, they all are the examples of the electromagnetic waves. So electromagnetic waves are propagated from transmitter antenna to the receiver antenna in the following ways. Number one is the ground waves. When the electromagnetic waves are propagated along the surface, the propagation is known as the ground wave propagation. Surface wave. When the electromagnetic wave propagates from transmitter to the receiver antenna without any reflection or refraction, then it is known as the space waves or space wave propagation. Generally, for our normal day-to-day life, we use the space waves propagation. Similarly, what is the sky wave propagation? The electromagnetic waves are propagated through the sky, and it comes up to ionosphere of the earth, and after that it got reflected and go to the sky wave propagation. So electromagnetic wave has the three types of propagation. Number one is the ground wave propagation. Next one is the space wave propagation, and sky wave propagation. So these are the electromagnetic wave propagation. As we discussed earlier, just one glance of the Maxwell's law. Maxwell's, as we discussed in the previous session, Maxwell's has the four law. Number one is the differential form. It comes from the Faraday's law. Grad cross E is equal to minus del B by del T. Where what is B? B is nothing but the magnetic flux density. This figure has been taken from the Bakshi's book. So this is the del B by del T, and E dot dl, this is the point form, and this is the integral form. E dot dl is equal to minus surface integral of del B by del T into ds. Then modified Ampere circuital law. Grad cross H is equal to J plus del D by del T, or H dl is equal to I del D by del T into ds. We got it from the modified Ampere circuital law, where J is the current density and del D by del T is nothing but the, what is del D by del T? Del D by del T is nothing but the displacement current density. Grad cross D is equal to rho B. This we got from Gauss law. And grad dot B is equal to 0. We got it from the modified Gauss law of the magnetic field. So the total electromagnetic wave equations are based on the Maxwell's equation. We will first discuss the electromagnetic wave equation in the free space. And in the free space, the current density is equal to 0. The volume charge density rho B is equal to 0. The permittivity of the free space epsilon is equal to epsilon naught. And permeability mu 0 is equal to mu 0 naught. What is epsilon naught? Epsilon naught is equal to 8.854 into 10 to the power minus 12, and this is 4 pi into 10 to the power minus 7. In the free space, in the vacuum, as there is no current, there is no conductor means no current, so J equals to 0. Similarly, if there is no current, charge is 0, and charge is 0 means charge means volume charge distribution or volume charge density rho V is equal to 0. These are the equation of the free space. So for the electromagnetic equation, this can be modified for the Maxwell's equation has been modified for the free space. And what are the modification? The new modified 4 equations are getting as first one was grad cross E is equal to rho V. As rho V is equal to 0, we are getting grad cross E is equal to 1. If we go in our previous section, you can get grad dot D is equal to rho V. Grad dot D is equal to rho V. This is the modified Gauss law. So what we are getting here? What is grad dot D is equal to rho V. D is equal to epsilon into E. So grad dot epsilon E is a constant, rho V by epsilon. As rho V is equal to 0, volume charge density is equal to 0, we got grad dot E is equal to 0. Next equation is grad dot B equals to 0. We can't do anything. This is the modified Gauss law. What is the third equation we got? We got first grad cross E is equal to grad B by grad T. So this is also same. This is also not changed. But grad cross H is equal to J, and as the current density is 0, grad cross H is equal to 0. But for the modified Maxwell's law or modified, we got that the J plus del D by del T. J is equal to 0, current density is equal to 0. So we got grad cross H is equal to del D by del T. So these are the modified Maxwell's equation in the free space. Gauss law has been changed into the grad cross E equals to 0. Number 2, grad cross B is equal to 0. Third one is as usual, grad cross E is equal to minus del B by del T. And fourth equation is grad cross H is equal to 0. And modified form is grad cross H is equal to del D by del T. So this is the electromagnetic wave equation. So based on this, we will discuss one more thing. This is the electric flux density. What is electric flux density or displacement density? When flux flows through any medium, the electric flux per unit area is known as the electric flux density. The flux per unit area is known as the electric flux density, and we can write D is equal to psi by ds. Psi is equal to total flux, S is equal to surface area. And as the surface area, as we are thinking, the surface is a big sphere. It is A by 4 pi r square, and Q is equal to Q by 4 pi r square. But again, what is intensity we got from the Coulomb's law? Q by 4 pi epsilon r square, and from there we can prove D is equal to epsilon naught into E in the free space. Now we will discuss the electromagnetic wave equation in terms of the E. E means electric field intensity. So we got already grad. We are starting from the Maxwell's. We are starting from the Maxwell's third equation, grad cross E. Sorry, one minus will come here. Grad cross E is equal to minus del B by del T. So what is we are getting? Grad cross E. We are taking grad in the both side, minus grad into del B by del T. So up to this is we got the modified grad equation. Now, as we discussed in the early class also, grad cross E means what is grad? Grad is nothing but the differentiation. Grad is equal to del by del T. So, if we take the grad of this equation, we will get first one is fixed and we are taking the differentiation of the second one. So, grad dot E into grad minus, now second one is fixed, grad dot grad into E is equal to, we are getting del by del T grad cross B. So this is the equation we are getting from here. First one is fixed, we are taking grad dot E into grad minus, second one is fixed, grad dot grad E and del by del T grad cross B. One minus sign should be here. Now, we got just from the modified Maxwell's equation for the free space, grad dot E is equal to 0. We checked it in the previous slide that the modified Maxwell's law in the free space, grad E equals to 0. So, what we are getting? Grad square E is equal to minus del by del T grad cross B. What we got? Grad squared E, sorry, not E square, grad squared E is equal to del by del T grad cross B. So, up to this is, I think it is clear. So, what is, and from the Maxwell's equation, if I go in our previous slide, first I will show the slide once, then it will be clear. In the previous slide, we got again grad cross E is equal to minus del B by del T. What is E? E is nothing but the epsilon into E. We got grad cross H is equal to del D by del T. We are taking the fourth equation. Grad cross H is equal to del D by del T, because this is an electromagnetic field. So, we have to think about the both equations. So, what we got here and what is H? H is nothing but the mu naught into B. So, we can write here. So, we are using this equation here. Grad cross H is equal to del D by del T. What is H? H is nothing but the B flux density by mu naught is equal to del D by del T. So, we can write grad dot B is equal to del D by del T into mu naught. So, if we substitute the value here, we will get del by del T. In the place of grad dot, we can write mu naught del by del T. In the del of D, we can write epsilon into E. We just got from the previous slide that E is equal to del by del T. So, we can write here again mu naught epsilon naught is equal to, I think I missed one grad. Mu naught epsilon naught is equal to grad cross epsilon square E by epsilon T square. So, we got this equation, and if we equate the both equation, what we will get? We will get grad square E is equal to mu naught epsilon naught grad cross del square E. Sorry, grad is not there. We have already moved this. We got grad square E by grad T square. So this is the electromagnetic equation. This is the electromagnetic equation in the free space. So what are the steps? I will repeat once. First we took grad cross E is equal to del B by del T. So grad cross E is equal to minus, we are taking grad both side, minus grad del B by del T. So grad cross E into grad is equal to minus grad square E. Del by del T, grad cross B. So grad square E is equal to minus del by del T, grad cross B. Now we got the equation up to this. We got the main equation up to this. Now we are going from the next equation. Next equation means Maxwell's fourth equation. What we got in the Maxwell's fourth equation? Grad cross H is equal to del D by del T. So grad cross H means B by mu naught is equal to del D by del T. So grad cross B is equal to grad del D by del T into mu 0. So in the place of grad cross B, we are writing mu 0, grad by grad T, mu naught E. So it is coming mu naught epsilon naught grad square E grad T. So grad square E is equal to mu naught F naught grad square E into grad T square. This is the electromagnetic equation. And again, what is we got again? See, the light of speed is equal to 1 by mu naught epsilon naught. So C square is equal to 1 by mu naught epsilon naught. So we can write one more equation, 1 by C grad square E, 1 by C square grad T square. So this is the electromagnetic equation in the free space in terms of electromotive force. So what is the final equation? Final equation we got grad square E is equal to mu naught this equation. Now we will discuss the electromagnetic wave equation for the space in terms of H. Similarly, we can start from the grad cross E is equal to del B by del T, and grad cross E is equal to minus grad del B by del T. Same we are starting. Similarly, we can write also grad cross H. What is grad cross H? We got J plus d by d into dt. This is the equation from the modified Maxwell's law. But in the free space, as we discussed earlier, current density is equal to 0. So grad cross H is equal to 0. Grad cross H is equal to d by d into dt. We got grad cross H is equal to d into d by dt. Now we are taking similarly grad in the both side, grad into grad cross H is equal to grad cross dd by dt. We are taking the grad in the both side. So again it will come grad fixed grad dot H into grad minus grad square H is equal to grad into grad cross dd by dt. Now again from the Gauss law, second Gauss law, we know grad dot B is equal to 0. What does it mean? Grad dot mu H is equal to 0. So mu H 0 means grad dot H. As mu is constant, we can write grad dot H is equal to 0. So this is 0. So we are getting grad square minus grad square H is equal to grad dot cross dd by dt. We will get this equation. Now what is the d by dt? D by dt is nothing but the grad cross epsilon differentiation of epsilon E into dt. or we can write more specifically grad cross epsilon is constant or epsilon naught, better to write epsilon naught as it is in the free space, grad dot d by dt into E. Now if we put the relation from this equation, what is grad cross E? Grad cross E minus del B by del T. And then we will again get the final equation. If we solve this, grad square H is equal to the equation. So we can use the equation in terms of H also. Grad square H is equal to mu naught epsilon naught grad square H by grad T square. If we put the value line by line, we will get the similar type of equation. Next line is, in the place of E, we should put the del B by del T. Del B by del T, because grad cross E is equal to del B by del T. So we will get again, okay, I will complete it. Epsilon grad cross del square B by del square T. And what is B? B is nothing but the mu H. So epsilon grad cross, there is no cross. So it is del square B by del square T. Grad cross E is equal to del square B by del square T. So what is B? B is nothing but the mu H. So mu naught grad square H by grad T square. So epsilon mu is equal to grad square H by grad square T. Again, what is the mu? It is nothing but the 1 by c square. C square means the light speed. So grad square H by grad T square. So this is the electromagnetic equation, electromagnetic wave equation in the term of H. So here we discuss the two important topic in this chapter. One is the electromagnetic equation for free space in terms of H. Another is the electromagnetic wave equation in terms of E. So what are the two equations we got? We got the first equation, grad square E is equal to 1 by c square del square E by del T square. This is the electromagnetic equation in the free space due to the electro field intensity. Another one we got, grad square H is equal to 1 by c square H by delta T square. This is due to the magnetic field intensity, where C is taken as 1 by mu naught epsilon naught, and its value is 3 into 10 to the power 8 meter per second, which is the speed of light. So this is the important thing. So the applications of the electromagnetic wave equation we will discuss in the next class in the quantum theorem. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.